All right, everyone. Welcome to our afternoon session. Our afternoon session will be led by Kieran Miller. I will do a quick introduction about Kieran. Kieran is the chief architect at Garantir, a cybersecurity company based in San Diego, California. With over a decade of cybersecurity experience, Kieran has expertise in multiple dimensions of enterprise security, from data security, identity and access management, to secure software development and network security. And Kieran will talk about a very interesting topic, SSH security, a scalable approach. All right, so I will stop my sharing and pass the control to Kieran. Kieran, all yours.
Thank you, Brian. As always, it's a pleasure to be here. As Brian said, I am the chief architect here at Garantir, and we're here to talk about a scalable approach to securing SSH. Now, before we can talk about how to secure SSH, we should talk about what the desired end state is. Of course, we want it to be secure. What does that mean? We want to be able to enforce strong authentication controls. We want centralized auditing every time a user authenticates. And we would ideally like to integrate with a federated identity provider. This could be Active Directory, Okta, or something else. On the usage side, pretty standard. We want high availability and performance as we would in anything IT related. We need to support all standard SSH tools across a multitude of operating systems. There are quite a few of them out there. And SSH is used by both human and automated systems. So you need to support both types of users. And then bonus points, if you can do this all without requiring a lot of software installed on the target SSH servers, or even better, requiring no additional software on them. And we want to be able to support third-party hosted SSH servers. These are servers where you don't actually control them. So you can't install software on them. You really can't do much in terms of configuring them. And then lastly, if you can take the same approach that you're going to apply to SSH and use it for other use cases like remote desktop, TLS, other things, that would be great as well, to have a consistent methodology across your use cases. So we talked about advanced security controls. What do we mean? There's really a lot of advanced security controls. Everyone thinks of multi-factor authentication. There's other ones like just-in-time access, IP address whitelisting, et cetera. Basically, these are the controls today. Tomorrow, they might be different. Whatever your approach is, it should support an abstract form of enforcing these controls so that you can centrally enforce these when the controls change at a future date. So what are the current solutions on the market at a high level? They basically look like one of these few. The first is a pluggable authentication module, commonly referred to as PAM modules. The second is a proxy server. And the third is a secret server. And then, of course, you can do a hybrid of these solutions. So the PAM module looks like this. Basically, you install the software on each SSH server, or the module on each server, and then the clients just directly authenticate to the servers, and the PAM module is enforced. The problem with the PAM modules is that you have to install the software and configure it, maintain it, et cetera, on each server. It's not a problem when you only have a couple servers, but the second you start getting a lot of servers in a scalable environment, this is a real challenge. The next issue is that on its own, the PAM module is not going to solve the management of your keys and secrets that you're using to actually authenticate to the server. Additionally, on its own, it's not going to provide centralized auditing of authentication. You can integrate it with a log aggregation platform, push your logs, and then centralize it. But on its own, the PAM module is not going to do that for you. And then lastly, the changing of security controls, you can't do that centrally with the PAM module. You have to go in, if you enforce one for multi-factor authentication, and then later on you want to add a new control in, you're going to have to go back to each PAM module, reconfigure it, possibly add some additional software. It's not very scalable in that approach. The next solution is Credential export. So in this case, what the client does is it talks to some secret server and authenticates itself to the secret server. And then if it's authorized, the secret server will release the secret that it needs to authenticate to the SSH server. So these secrets are typically passwords or SSH keys. So the client actually gets access to that secret. So the challenge with this approach is really all stems from the fact that the secret is exported to the client, which makes it subject to compromise. So what you'll see these systems do is they'll start to rotate the secrets frequently, basically to try to compensate for the fact that the secret is exported in the first place. So it's kind of just a band-aid on an overall problem, being that the secret was exposed. You also can't guarantee centralized auditing every time the secret's used. You can centrally audit it every time the secret is exported, but once the secret is exported, it can be used multiple times. So you can't get centralized auditing every time the secret is used. And then the last solution is a proxy. And this is where the client actually talks through some proxy, which then talks to the backend SSH server. In this challenge, so there's a number of challenges that kind of combine here. One is that the proxy is a high value target for attackers for obvious reasons. The second is that the proxy has a large attack surface. So what we mean by that is that the proxy has to take basically any command as input, and then also has to take any output from the SSH server, and it has to, so allowing any input and any output, it leaves a large attack surface for attackers to play with. So this combination of being a high value target and a large attack surface is what is problematic. There's, of course, anytime you introduce a proxy, there will be availability and performance concerns with additional network hops. And then on its own, it does not solve the secrets management problem. You can, of course, integrate the proxy with the secrets manager, but on its own, it typically doesn't do that for you. And then lastly, in some cases, the proxy won't work with standard SSH tools. So some proxies actually will expect you to talk to the proxy via a web browser. So it'll expect HTTP traffic on the inbound, and then it converts that to SSH. But if it doesn't support SSH traffic on the inbound, then your standard SSH tools won't work with it. So a better approach is one that we use in our product called GaraSign, although it's not specific to GaraSign itself, is basically you have the SSH client. It wants to talk to the SSH server. So it initiates a request to talk to it. The SSH server then sends back the authentication challenge. This is just part of a normal SSH challenge response handshake that's supported natively. Then what the SSH client will do is it will actually authenticate to GaraSign, and it'll do whatever it needs to do: multi-factor authentication, device authentication, whatever controls you want to enforce. And then what'll happen is if those all pass, GaraSign will then offload the signing to a hardware security module where the key for authentication actually resides. So the key is in a non-exportable state in the HSM. That signature result will then be forwarded back to the client, which then gets forwarded to the server. And then once that's validated, the process completes and the session is generated. So 1, 2, 6, and 7 are a normal SSH challenge response handshake. 3, 4, and 5 are what's unique here. But what you'll notice is that from the SSH server's perspective, all it sees is 1, 2, 6, and 7. It doesn't know that you're doing 3, 4, and 5. And the benefit of that is that it doesn't need to be instructed with additional code or anything like that in order for this to work. From the SSH server's perspective, you just completed a normal challenge response handshake. It doesn't know that you had to do MFA. It doesn't know that the key was in the HSM. It doesn't need to know about all that. So this approach has a number of benefits. The first is that the key is never exported to the client, unlike the secrets manager case that we showed earlier. In this case, the key is always protected inside the HSM. As a result, there's no need to frequently rotate keys as a band-aid to exporting the client or exporting the credential. Additionally, every authentication can be centrally audited because the keys never export. The user we can see every time that the key is used. The connection to the server is not proxy. So we are only proxying the challenge response handshake. After that, everything is direct between the client and the SSH server, and this solution is not involved at any point thereafter. And this will work with standard SSH tools, and there's no need to install software on the SSH server. So there's a big administrative headache that's alleviated with this approach. And then lastly, this methodology can be applied to other use cases like RDP and TLS. We probably won't have time to go over that today, but this same approach can be applied to a number of other use cases. So what does it actually look like in using a standard SSH tool? So in this case, we're using WinSCP to do SSH using the key that you see right there highlighted. So using WinSCP, we're going to go ahead and SSH to a server. And you'll see that it successfully authenticates. So now to prove we're using this key that's in the HSM managing GaraSign, we're going to disable the key and then reattempt authentication. And this time it should fail. So there's a retry mechanism in the background. So it's retrying, but ultimately it fails because the key is disabled. So we know we're using the key in the HSM proxied with GaraSign. Now we're going to reactivate the key. And we're also going to change the key's policy to one called MFA required. So even though there's no custom software on this target Linux server, when we authenticate, it's going to prompt us for multi-factor authentication. In this case, the multi-factor authentication is TOTP codes, but it could be FIDO2 or anything else. It doesn't matter the form of MFA. And once the MFA completes, you'll see we successfully authenticate. So we were able to transparently enforce multi-factor authentication, even though the target Linux server had no concept of multi-factor authentication whatsoever. We didn't have to install anything custom on that target endpoint, and yet we were able to achieve that. Additionally, that earlier part of the demo where we disabled the key and then reactivated it shows how you can enforce just-in-time access. You could actually keep your keys in a disabled state by default and then only activate it when there's a need to use it. For example, when a ticket request is approved to make a change to a production system. So break glass capabilities, what happens if, in this case, GaraSign goes down? How would you continue to access your systems? So today, we've never had that happen. It all deploys in a high availability cluster. But let's say that it does happen. What could you do? You can still deploy with what we call break glass capabilities. And basically the way it works is you take these break glass private keys and you store them in a safe, preferably on a smart card or a YubiKey or something like that. And then you push out the public keys that correspond to those private keys out to your servers, and you configure them in these the authorized keys file for predefined super users. And if you ever had a case where you were unable to access GaraSign, you could use the private key in the safe to authenticate to the SSH server and continue working. You would still have access. So ultimately, when you compare the different approaches, lo and behold, of course, our solution we give all the green check marks to, but there's a reason for that. We're not just trying to pick, features to highlight. We were actually looking for a solution for ourselves, for our own internal use, and we didn't like what was out there. And that's why we came up with this approach of controlling SSH, and then find out that it's applicable to a lot of other use cases. Now, a common question is about key rotation. Right? How does the solution work when you need to start rotating keys? Well, first of all, since the keys will always remain in the HSM, the key rotation is needed far less frequently. So NIST actually provides some guidelines on how often you need to do that. Basically, for these authentication keys, rotations needed about every 1 to 3 years, depending on some parameters of the keys. So you'll only have to do this rotation quite infrequently. But that said, there's 3 approaches to key rotation. The first is called public key push. The next is using SSH certificates. And the last is using the authorized keys command. So the public key push looks like this. GaraSign basically pushes the public key for each user out to the SSH server, which gets configured in the user's authorized keys file, which is where SSH natively looks for to find the user's public keys. So the pros to this approach is that you don't need any software needed on the SSH servers. And it's really a tried and true approach. You'll see this with other systems as well. Basically, automatically writing to the authorized keys file is a very common approach to pushing public keys. The cons, it's possible to have a synchronization issue, especially if a key is rotated and a push hasn't happened yet. This is really easily mitigated by just putting a decent window of time between rotation and pushes, but it is theoretically possible to have an issue there. The second approach is to use SSH certificates. Now you'll see that this looks very similar to the public key push, except we're now pushing an SSH CA certificate. If you're not familiar with SSH certificates, it's similar in concept to the PKI or X509 certificates you'll have from your standard PKI, but under the hood, it's different. It's different data structures, and there's some nuanced differences, but at a high level, it's the same idea. So in this case, instead of pushing out the public keys for each user, you push out the SSH CA certificate to the servers, and then the client authenticates as it normally would. So in this case, the pros are, again, no custom software needed on the SSH servers, and you only need to push the CA certificates one time, as opposed to the public key push where you have to push out every time the key rotates, so every 1 to 3 years per user. In this case, you only push it out once. And the solution, despite that it's not often talked about, it has existed for a long time. On the cons, not all SSH servers support SSH certificates. A lot of them do these days. In fact, I might even say most of them do these days. But you will find routers, switches, and legacy systems that are out there that possibly don't. And then the last approach is called the authorized keys command. So in this case, what happens is when the client authenticates to the SSH server or attempts authentication, the server will actually it'll execute this authorized keys command, which will talk to GaraSign and say, I want the public keys for this user. So it's basically saying in real time, it's saying, give me the public key for this user at the point of authentication. So the pros for this approach is that it ensures real-time update of the public keys for each user. But on the con side, it does impact performance during authentication. There is an extra network round trip on every authentication call, and it requires software to be installed on each SSH server. So you don't have to use one approach. You can mix and match as you see fit. So for example, a common approach is to use SSH certificates for servers that support it. Then for everything else, you use a combination of the authorized keys command and public key push for your highest value servers, and then just use public key push for the other servers. Of course, this is just an example. You can use whatever makes sense for your environment. So then you run into an enterprise deployment. How can you actually deploy this kind of solution in an enterprise? Well, basically, you're going to have two types of SSH servers. The first is your new SSH servers. So things that you deploy net new, think EC2 instances in AWS or that kind of thing. These are really simple to deal with. You basically just add the public key or the CA certificate at deployment time and call it a day. Then you also have your existing SSH servers. For this, you need to follow a more methodical process. So the challenge with the existing servers is that first you need to know the inventory. Where are these SSH servers? After you find them, you're going to need to be able to authenticate to them. How can you actually authenticate to them in the first place? Because if you're going to push public keys or CA certificates, you're going to need to get access to those boxes to do that. So what authentication methods are supported currently, and where are the current credentials for those machines? Then you're going to need to figure out the authorization, right? So who's allowed to authenticate as which SSH user? So a lot of times these SSH servers are not domain joined, There's no mapping back to Active Directory or whatever your federated identity provider is. So how do you map these Linux users, these local users, to your IDP? And then supported platforms, you're going to run into a lot of different types of SSH endpoints with different capabilities. So you need to be able to support all of them. And then lastly, sensitivity. I mean, SSH servers are commonly running very sensitive workloads, production systems, things like that. And there's little to no room for downtime. So you need to be able to do all this without having to bring anything down. So the robust approach to doing this, the first step is discovery, where we're actually going to go out and find the SSH servers that are out there. Once we do that, we're going to do an inspect step, where we'll actually inspect the servers, see what's on there, find out the current state of that machine. Then we're going to do a correlation step. This is an interesting part, but that's where we correlate the users, the local users, to the federated identity provider users. Then from there, we're actually going to start making changes. This is where we do a merge configure. So in this case, the goal is that you don't block any existing users from authenticating, even with the credentials that are not in the HSM, but you also add the new HSM credentials. So the goal is at the end of this step, you'll be able to authenticate with your current credentials, as well as the new credentials in the HSM. After that, you would actually do a reconfigure. At the end of the reconfigure, you'll only be able to authenticate with the credentials in the HSM. Those old credentials will no longer work anymore. And then lastly, you need to monitor and maintain this whole solution. You'll notice there's some notify sub-steps under these, because you need to notify teams as this process completes so that they can be prepared to say, hey, we've done a merge configure. You have X amount of time to migrate to the new credentials, after which your old credentials will no longer work. So there's more to discuss. We know we're running low on time. Let me see how much time we have left here. We actually have a little bit of time left. So I'm actually going to go back and talk a little more about that process, which originally we were not going to do, and talk about how to do the discover, the inspect, etc. So from the discover, what we're going to do, the first thing we're going to do is we're actually going to discover the SSH endpoints in the enterprise. We're really just looking for the host, the port, and in some cases, the server public key. The way we do this, the primary method is port scanning. Port scanning works pretty well. In large enterprises, you can have different network zones. So you may run into some issues where you actually need to run the port scanning from multiple zones, but ultimately it's the same idea, just port scanning across all your different network segments. And then secondary method, you can actually integrate with existing inventory databases reports. So, your cloud administrative panel will have access to, your EC2 instances. You might use something like ServiceNow that has a report that's already readily available. You can also pull from that. Once you've discovered the endpoints, you want to inspect them. So this is where we want to connect to each server and retrieve the software version, the SSH configuration, the list of users. Basically, it's a read operation on the server. To do this, it requires access to one or more credential repositories. So typically, these are things like CyberArk, HashiCorp Vault, things that are currently used to store credentials. These are your typical secrets managers that export credentials to the client. So you want to connect to these, pull the credentials down, use them to dynamically authenticate and do the inspection step. And then servers whose credentials cannot be retrieved programmatically, you basically log those for manual intervention. Then you get to the correlation step. This part's kind of interesting. This is where we actually need to map the SSH users to users in the enterprise IDP. So we ideally want to handle both human users and service accounts. So the common approach to doing this is to inspect the authentication credentials in the credential repository and then map those back to the permissions. So you can see, well, this user in the IDP has permissions to these credentials on the box. Therefore, this user can access this user account. There's other ways to do it too. You can correlate IP addresses from the login history for the users, which you can get from the SSH server. It's not a foolproof method. A lot of times there's bastion hosts and things like that used, so the IP addresses won't really map back to the individual user. You can also, if naming conventions were used, you can follow that. That's not really a great approach though. Really, the inspecting the access to the authentication credentials is the best bet. And then, so if the credentials for all the SSH users are stored in the credential repository, it can be possible to fully automate this. But like the other slide, otherwise manual review and intervention may be necessary for certain users on the box. So now we get to the merge configure step. This is where we actually start making some changes. So this is where we'll generate new keys for each SSH user in GaraSign. Optionally, you're going to issue certificates if you're using the SSH certificates. And then you're going to push the new public keys or SSH CA certificate to the SSH servers, but you're going to leave the existing credentials and configuration as well. Okay, so this is the merge part. So this is achieved by merging the global and/or per user SSH configuration. And then, so optionally, you're going to create a new GaraSign pseudo user with credential in the HSM for future access. This just makes sure GaraSign can authenticate back to the SSH server periodically to monitor the system. And then the result of all this is that users can authenticate with their existing credentials or the new credentials in GaraSign. Either one will work. And then at this point is where you notify teams to start migrating to the new HSM-backed GaraSign credentials. Now we get to the reconfigure. So you've notified the teams they've had sufficient time to migrate to the new credentials. So now what we're going to do is we're going to remove the legacy credentials from each server. And then, but of course, leave the HSM-based GaraSign credentials in place. And so the result is from here on out, users can only authenticate using the keys in the HSM proxied by GaraSign. And so you can enforce all these controls and be sure that that's the only way users can authenticate. And then lastly, of course, you need to monitor and maintain the system. So you want to monitor invalid login attempts for each server. And then for each invalid login, you want to check if the user has credentials in GaraSign and notify them to make use of those credentials. And then you want to detect unauthorized system-wide or per user configuration changes. So basically anything that's trying to revert the configuration back to the old approach for authentication, you want to detect those and automatically override those. So that is it. I appreciate everyone's time. I'm going to pass it back to you, Brian. See if there's any questions.
Great. Thank you very much, Kieran. This is a very comprehensive talk about SSH security, and also covered all the stages. So for people not familiar with this topic, you also get an educational component about it, the landscape of this one. Some of the component, of course, is quite technical. We do have a couple of questions regarding for example, you mentioned you use HSM in this process. Is that like a mandatory to use or it's optional?
That's a good question. So it's highly recommended. The HSM buys you a lot of compliance and certification of core security. But no, it is not mandatory to use an HSM. Really, the idea is just to proxy the keys away from the end user. That's the real goal. Ideally, the keys would be in an HSM though as well to further protect against attacks where keys get stolen, from administrators that have access server side and things like that.
Okay, all right. So it's not 100% mandatory, but it's recommended.
Correct. Yeah, it's all best practice. Yes.
Okay, and the other one is regarding the implementation. So does it only work as on the cloud or like a SaaS application, or can you host it internally on premises, all those things?
Yeah, good question. No, so both. You can of course consume it as a SaaS, but we have customers, utility companies who are in OT environments that can only be on premise, and they deploy this on premise and they run it themselves. So it is either option works.
Okay. And last question really is implementation effort. So for team to incorporate this one, is that like a big effort to ask, or like it's a fairly easy, straightforward process?
Yeah, so the answer to that has levels to it. The first is, how do you deploy the software itself? That's easy. That takes 3 days and you're deployed 2 environments, non-production and production, 2 more days for training. The rollout for the SSH servers, for new servers, it's literally a click of a button. For the existing servers, that whole process that I showed, for typical enterprises to roll this out to the entire enterprise, so large Fortune 500, it takes them about 6 months or so to really roll that out to all the existing servers that they have out there. And that's more to be cautious, put ticket requests in, all that kind of stuff. That's what it takes.
All right, very cool. All right, so thank you very much, Kieran. That's all the time we have. And we record the session, so for people miss some component or want to review afterwards, so once Kieran approved the video, you can also watch that one. Again, thank you very much, Kieran, and also thank you for watching this presentation online.
Thank you, my pleasure.
Yeah.
Take care.
All right, bye for now.